Hi guys, I'll keep this fairly short and snappy because I know I'm between you guys and more pizza and asking architects things. So just for a quick overview, what I'll present is a very high-level overview of Qubole. I'll give you a few use cases. I'll go through a couple of recent use cases and scenarios from the kind of insights that we gain from this kind of work. And then I'll hand over to Sudha to present the kind of walkthrough of the Qubole dashboards, how to use Qubole, how to do some processing of data, ingestion, and so we'll split it that way.
Do you want to hold your mic?
Yeah, I'll hold it a bit closer. Is this the old version? So actually, I thought I'd share this quote with you guys. So it's such a changing and variable landscape. There's so many products, it can be difficult to keep up with them. So we've got words like Hadoop, Hive, Spark, some words which we wouldn't have even heard of 4 or 5 years ago. And you'd expect them to find these kind of words in Dr. Seuss tale. And I think the big data world is a different kind of nonsensical story in many ways. It's kind of sprung up from nowhere, and it's a very interesting landscape. But I think where there's hype and where there's a lot of focus, a lot of buzzwords, a lot of interest, there's also opportunity. And in data consultancy, really, it's that opportunity that we're really trying to leverage. With Qubole, really what we're trying to focus on is that the platform shouldn't be the end. We're not here to focus on the specific technical solutions. What businesses need is answers to their problems, and they need a platform that gives them the answers to their key business questions. So some of the big data challenges that we come across quite frequently are things like the cost or scalability of a particular solution. You've got operational challenges. You don't want to have your data scientists and engineers spending their time architecting a solution or maintaining, deciding what kind of resources to allocate to a Hadoop cluster, deciding how best to optimize their code, how best to optimize their servers. So really, with the whole idea of big data as a service, what we're trying to do is relieve data scientists and engineers from the more tedious tasks so that they can really get on with the core business questions and answering the core questions which come from the business, which is really where they drive value. So to give you a few example insights, I've got 4 examples up there. I think we'll focus on the first 2 because we are quite short on time. So consumer goods and retail sales. A couple of recent pieces of work. So for consumer goods, an example that I'd give there of a recent project where we've utilized these kind of platforms and a modern data architecture is in, for example, the sales of a particular type of consumer goods. And we gathered a set of disparate data sources. We presented that in traditional BI methods. And really where we started adding value is when we could start answering business questions as and when they're thrown at us, and also kind of through exploratory data analysis, figuring out things that the business hadn't even thought to ask us yet. So an example of that is with a particular CPG company. From their normal BI reporting, we managed to extend that to include information on sell-in and sell-out, and kind of figuring out how their promotional activity affected that. What we managed to figure out was how their promotional activity impacted sales into distributors, sales out of distributors, and it's focusing on those kind of business problems that I think is really key in this era of big data. Not so much on a specific platform or on how many nodes does your Hadoop cluster have, or how many layers does your neural network have. Focusing on the technology is one thing, but focusing on the key business questions and on kind of delivering actionable insights is really where we at Savello really put our time and effort. And to give another example in retail sales, we've recently been working with a large retail goods company. They have particular contracts in place to try and optimize their sales. So they're looking into which specific contract terms will drive sales, which ones will get them better placement on store shelves, a lot of different metrics which go into their contracts, a lot of effort and a lot of money which are being spent, and really very little analysis of the data and little knowledge on what impact all of that expenditure and effort actually has. And so with our recent data science project, we went in, we blended together some of their internal data sources, and what we came out with was a few key insights which could quite drastically change how these millions of pounds worth of expenditure will actually impact the business. And for me, and I think for a lot of data scientists, it's really seeing those actionable insights taken into account and really being seen by the business that is the reward in the job. It's not so much the technical problem, not so much the technical challenge, although that's an enjoyable exercise in itself. Being able to focus on the key business problems and drive actionable insights and to drive the business forwards, that for me is where the excitement in these projects lies. So let's go through a quick demo storyboard. As Hitesh mentioned earlier, he gave you a very broad overview of the kind of art of the possible with Qubole. What we've got here is a couple of use cases. So we have our data being landed from S3 into Snowflake. From Snowflake, we have direct querying at rest as an ETL process presented in the traditional BI tools. That's your Looker, your Power BI, your Tableau. We also have the more interesting features, the in-memory querying, the notebooks, the very language agnostic approach to data science. And what we'll show you now, I'll hand over to Sudha, is how that process works and how we can land that data in Tableau, in your choice of BI visualization software. So I'll hand over to Sudha.
Thanks, Hira. Can you all hear me okay? No. Hello. Hey. Is this better? Yeah, okay. So thanks for setting the context, Hira. And, we've been talking about Qubole in this framework of big data all evening. And so I'm sure you're very curious to know what it actually looks like and what it actually does. So we built out this, I wanted to do a walkthrough of the Qubole interface and then also sort of go through a notebook in which we build a very simplistic data science in a retail data setting and then just talk through the processes. Oh, fuck. Sorry, I need to change my account. But so this is what Qubole looks like. I access it through this website, and I think it varies based on where you are. But basically, this is the interface that you first, how you first interact with Qubole. And here, as Ajith just pointed out, you can have different accounts. I have a personal account as well as my company's account, and so I have to switch accounts. Here's this. Here's where you would sort of, manage your clusters as well as create new clusters, turn it on, off, whatever. I've got Spark and Presto clusters on because I'm doing a lot of data science, PySpark modeling, and it works best with Spark. And then Presto because we're connecting to Tableau, and then Tableau works really well with Presto instance. We're not using Hadoop much, but we also have that provisioned. In terms of the layout, the key points, I think if you go to Explore within this drop-down menu, what you see is all the data store, database, data that you have access to. So we talked a lot about connectivity of data and how you can connect to, data from different sources. For example, S3 or Hive or Snowflake. And here we have this S3 where we have a few tables saved, and then we can work through that. We also have these Snowflake accounts connected, and we also have this base sort of Hive, Qubole Hive data store. So in the analyze, this is basically for folks who've used, R or all these programs. You're used to seeing this kind of setup where you have queries on the side. You can write all these queries. You can choose the instance. For example, here, running on Presto, run it, and then what's interesting is that it also maintains history. So you can go back, identify your query ID by this unique query ID, and then go back and troubleshoot if needed. And then you have the results, logs, the usual stuff. There's some bits about scheduler, so if you want to have a regular ETL jobs, there's that option. And then, there's clusters set up, and we've talked a lot about this, the advantages and disadvantages of different clusters, Presto, Hive, Spark, quite a bit. And I'm going to sort of switch over to Ajith, ask an architect, so he can talk a little bit about how to provision new clusters and settings that you would have.
Sure. Hey folks. Hello. Hello. Okay. This one is for you, right? All right, thanks. Hello. Can you guys hear me? Okay. All right. So as Sudha pointed out, this is let me introduce you to the concept of active and inactive clusters in this page, right? So what we're talking about, and all evening we said, split compute and storage. So the previous era was data locality was a big deal, isn't it? So you put all the data into a Hadoop HDFS cluster, and then you run your compute on that same cluster. But then soon you'd realize that you can't scale up as much as we would have liked. So here is the demonstration about active and inactive clusters. The clusters in Qubole are ephemeral. Right? So what that means really is that some of these clusters come up when a query is fired against it, and it takes about 3 or 4 minutes to come up, largely spent on AWS or Azure provisioning those virtual machines behind the scenes, and for us to bring up the services, be it Spark or Presto or Hive. And once it's up, you get to use, either run through the analyze UI that Sudha just talked about, or the notebook interface that she's going to talk about in a bit. So that's active and inactive clusters. The clusters basically come up when you first fire a query against it, and then or a command issued against it, and then it stays up for an idle timeout, and it shuts itself down. So in the meantime, if there is somebody else who's coming in and submitting the query or a command to that same cluster, the cluster may scale up. Again, we do an aggressive scale down, but we do a very lazy upscale before that. So which basically means that we are packing all the containers and all the compute instances are basically in yarn terms containers towards one side of the cluster, so that the other side of the cluster is kind of free to scale it down, right? So does that make sense? Okay. So otherwise, in Hadoop, in traditional Hadoop, what it means is just basically shards. It just sprays all over. The containers can be anywhere. So you don't really get the power of downscaling. You can't do downscaling that easily. Qubole, on the other hand, has solved that problem to compact or pack the containers towards one side of the cluster, so that the other side is free to scale down and bring down your total cloud costs, compute costs. Right? So with that introduction, creation of the cluster is pretty easy. There's a small wizard, not really very fancy UI, but works nonetheless. So you have Hadoop 2, which is what we recommend. Hadoop 1 is there because we've existed as a company for 7 years, and before Hadoop 2 became really popular, we had to support some customers on Hadoop 1 as well, and that continues to remain. But those companies, the early adopters of Qubole, are now kind of moving to Hadoop 2, and slowly this would be, there'd be an end of life kind of a thing. Why do we have different clusters? So the obvious question that you guys may ask is, why can't we just have Spark and Hadoop sit together, or Presto and Spark together, or something. So that sort of interferes with our scaling up logic. So we kind of split the cluster types because we don't really impose any restrictions whatsoever on number of clusters, a number of accounts that you can create once you sign up. So what we recommend instead is, if you have a machine learning or a data engineering job, which is Spark, you create a Spark cluster for it. If you have legacy Hive applications, you create a Hive cluster or a Hadoop 2 cluster for it. Analytics workloads, create a Presto, and then there is a simple scheduler that Sudha just mentioned, or you could use a more robust and well, I must say, a well-designed scheduler like Airflow. You could probably use that for your scheduling and orchestration requirements. Now, don't want to take a lot of time, but then just create a simple cluster here. You can choose the Spark version, right? So I'll use the latest Spark version that we have. By the way, 2.3 is getting released in a few months as a preview. Open source already has it. So we play a little bit of a catch up there from open source, but then what we're doing essentially during that time is we are putting together all the, we're basically testing for production use, so that when we put up over there, it's ready for you to consume it, right? So give it a label. I just say, meetup demo, right? So what I'm doing is creating a cluster here, and here you may notice here we have a minimum and maximum. I just set it to 2 and 200. So when you first submit a query against this cluster, either a Scala code or machine learning algorithm written in Python or R, 2 nodes will come up. That's the minimum nodes. And then if your colleague, a fellow data scientist or a data engineer, uses the same cluster and there are more jobs run against it, it scales up all the way to 200 in a lazy way, right? So we're not aggressive about scaling up. So that's the 200 number there. So how do we come up with this? You come up with some sort of let's say your application architect or performance engineer determines what's the peak requirement of the cluster, and then you set it to that high number. But that's never hit. That's only hit during the peak time, right? So that's that. And then you have all these region support and so on. I skip over in the interest of time. By the way, this is all AWS, so very similar in Azure as well. So you may just want to, but we don't have the Spot instances in Azure. That's the only difference. Holden talked about the Spot composition. So this is the bidding part. So you set the policies here. Here you're basically saying that, what you're saying here is go up to 100% of on-demand cost, which is 66 cents over here. So go all the way up to 66 cents for Spot nodes, but get a Spot node only if it's lower. So you keep bidding until you hit that number. So that's 100% Spot, and then you 50% of the cluster. If it's 200, at most there are going to be 100 auto-scaled Spot instances in that cluster. Okay. Lastly, sorry, Sudha. Lastly, there are some Hadoop and Spark configuration settings and EC2 settings that you can put together and then hit create. And that's how you create the cluster, and then she's going to show you.
I think I'll take over. Yeah. So once we do all the boring stuff, now you get to, like Hira said, we're not interested in the back end. So now you actually have the notebook set up, so you can actually get started with doing real analytics or data science. So we previously talked about connectivity with different data stores. And so here, what I've attempted to do is sort of create a simple ETL workflow so that you ingest some of the data. I'm ingesting data from Snowflake, and then do some very, just for the purpose of this demo, do very simplistic transformations, and then put that data back into, I'll save the data back into Qubole, and then also put it back in Snowflake, because you also want to sort of close the loop of ETL and put it back in your data warehouse. And then use that data to sort of create a machine learning model. So there's this what I've done here is used Spark and then Scala to actually read the data in, created temporary tables, and we're going to be rushing through this because we're really, we need to hurry this up. But after that, as you can see in the Spark cluster, I can also run SQL, like we talked about before. So here, I'm creating a temporary SQL table, doing some data transformations, just to show you that the table actually got created. This actually runs, and you actually get a transformed view of the table that we did have earlier. And then something that we didn't talk about earlier was that the Qubole does have a visualizer as well, and I see it as more as a sort of data engineer's visualizer, where you're processing lots of data and you just want to sort of quickly look at how the data actually looks and what the sort of what the data what the data looks like, basically, before you actually do any modeling in it. And you don't necessarily want to write a long matplotlib code or connect it to a BI connector. You just want to do it within the same notebook. And so this is very simple code that I wrote, and you could present it as a table, but then also present it as a visual. There's another example of a visual. I like that, I'm just here, the data, actually I should give you some context. So the data I ingested is a retail customer's data, and it's very simplistic, and what it contains is contains the channel that its products get sold through, and then contains a hierarchy of the brand that they're selling, and then looks at across years and periods, which is basically month, looks at what the revenue looks like and what are the discounts that they're providing. So what I want to do is look at how discounts are impacting revenue, whether or not giving more discounts has actually any impact at all. The reasoning behind discounts is that you're actually going to sell more and then get more revenue, but if you're not doing that, you're actually losing out on revenue, and there's no point. So to derive that business value. And so here I'm just looking at the distribution of revenue with discount. You're seeing discount in the negative y-axis. And here it's grouped by, I want to see if that changes across different kinds of products. And so it seems like it stays pretty consistent because across different products and also across different channels where you sell data. And so it seems like it's staying pretty consistent where, except here where it seems like discount has a high impact on the revenue. And so now we have that, and now now that I've actually transformed the data, I want to save that data back. So I want to save it in Qubole first. So here's the actual table that I created from the SQL temp table that I created, and then if you hit this command, very nifty, where what it'll do is within your process, it'll tell you all the tables that you have, temp tables versus permanent tables. So you can see that I had that temporary table here, and then I sort of created this new table, which, sorry, that's also temporary. But demo retail is the new table that I just created here. It's not temporary. And then now that we've done the ETL process, we want to save the data back into our data warehouse, which is Snowflake. And so I write some Scala command to read the data back into Snowflake, just following syntax. And then now I want to use the data that we do have to write Spark commands, so we can actually do some interesting analyses on it. And so here, this is me just defining data frames and looking at the data. Here I'm looking at the summary of the data to see how what the sort of data looks like in terms of counts, mean, standard deviation, the usual stuff. Then I'm looking at the sort of correlation between the revenue and all the other factors here, just to understand what the data looks like. We get correlation based on this. I sort of select the features, and then I split the data set. I run the model. I look at the parameter, and then I have that data set. I also do some model fitting. Again, I have that data set here. We calculate residuals, so sort of look at how well the model predicts the data. And that is it in terms of Qubole notebook that I have created for this. Now I'm going to hand over to my colleague who's going to talk about sort of a link to BI tools so that you can actually look at these data.
So I'll keep this fairly quick. Basically, from there, we had the option to configure ODBC connectors into any of the major BI platforms. So for example, here we've pulled the data into Tableau. We've got some visualizations where that's, and the dangers of a live demo, hey? Yeah, effectively you can do whatever visualizations. This is the same kind of process we used in the retail example I gave before, where this was the start of the data visualization process. We had some exploratory analysis. From there, we ended up with insights that we took back to the business. So it's your choice of BI tool that you use over this. I think there's a definite distinction between the kind of tools which you'd use for your data engineers and data scientists, like the built-in Qubole tools, and the kind of tools which you're going to use to present the data back to the business. But yeah, I guess that concludes our talk.